When you look at the center of the Milky Way, you are seeing an active battlefield. Every star in the night sky is currently fighting a billions of years long war against its own weight. We can trace the origins of this conflict to massive, freezing molecular clouds of dust and gas drifting through interstellar space. Inside these stellar nurseries, the gas maintains a structural balance until it hits a specific mathematical threshold known as Jeans instability. At this exact point, the internal pressure of the cloud fails and gravity takes over, pulling the surrounding material inward. The immediate aftermath is violent. The collapsing cloud compresses rapidly, spinning faster and faster into an accretion disk. The densest material is forced into the center, igniting intense friction and forming a tightly packed sphere called a protostar. It is a cosmic paradox. Gravity physically forces the star into existence by gathering this material, but it immediately begins a relentless campaign to crush that same material into nothing. To survive, the protostar must mount a defense. As gravity squeezes the core, the internal temperature rises to millions of degrees. The pressure becomes so intense that hydrogen atoms smash together and fuse into helium, triggering a chain reaction of nuclear fusion. This diagram illustrates how the star survives. The massive red arrows represent gravity pulling inward, but fusion generates a massive amount of outward thermal pressure, shown by the yellow arrows. When these two forces match exactly, the star achieves hydrostatic equilibrium. We refer to this active standoff as the main sequence. Our own sun is currently in this phase, burning through massive reserves of hydrogen every second to hold back its own crushing mass. This is a war of attrition. The star relies entirely on a finite supply of nuclear fuel to generate its outward pressure. Gravity requires no fuel, and its inward pull is inexhaustible. For stars under 8 solar masses, the initial defense eventually falters. When the core runs out of hydrogen, gravity immediately compresses the star further. The star swells into a red giant and begins frantically fusing helium just to keep gravity at bay. As we see in this image of the Cat's Eye Nebula, the star eventually loses its grip. It sheds its outer layers of gas entirely, creating a planetary nebula and leaving behind a dying, exposed core. This animation shows the core's absolute final line of defense. As gravity squeezes the remaining matter, quantum mechanics takes over. Electrons are packed so tightly they cannot occupy the same state. They resist being compressed any further, a rule known as electron degeneracy pressure. The result is a white dwarf. It is a dense, dead monument to a cosmic stalemate where the basic laws of quantum physics barely halted a total gravitational victory. If the original star is heavier than 8 solar masses, the rules change. The gravitational weight is so immense that the electron barrier simply snaps. The collapse is completely catastrophic. The outer layers immediately detonate in a supernova, while the core undergoes rapid neutronization. Gravity forces electrons and protons to crush directly into one another, fusing into a dense sphere of pure neutrons. What remains is a neutron star. It is an object the size of a city, spinning rapidly, with an interior theorized to contain bizarre structures known as nuclear pasta. It is held up entirely by neutron degeneracy pressure, the last physical barrier available. A neutron star is nature's most extreme compromise. It survives on the absolute razor's edge of total collapse. There is a final class of stars, the ultra-massive giants. For these stars, the gravitational weight is so overwhelming that it shatters even the neutron barrier. With no physical or quantum force left in the universe to oppose it, the core matter collapses infinitely inward into a singularity. Looking at this render, the dark void in the center is the event horizon. This is the absolute boundary around the singularity where the gravitational pull becomes so severe that not even light has the velocity to escape. This is gravity's absolute and final victory. The star's matter is effectively erased from the observable universe. These stellar remnants drive the evolution of entire galaxies.
Their interactions determine how matter is recycled and where the next generation of solar systems begin. This visualization shows the gravitational waves generated by two merging black holes. As they collide, they release massive pulses of energy that ripple through the four dimensions of spacetime, stretching and compressing the distance between objects across the universe. When neutron stars collide, the resulting kilonova explosions trigger R-process nucleosynthesis. In the sheer heat and pressure of that impact, the universe's heaviest elements, like gold, platinum, and uranium, are forged. We can see the outcome in this image of the Orion Nebula. These violent deaths scatter those newly forged elements across the interstellar medium, enriching massive gas clouds to prepare them for the next generation of protostars. The lifelong war against gravity ultimately destroys the star, but by fighting and losing that battle, the star distributes the exact elemental building blocks required for planets, moons, and life itself.